Hello everyone, welcome to my YouTube channel AV Classes. Today let's discuss the theory of interference fringes. We had already discussed the condition of constructive and destructive interference in the last lecture. For constructive interference, the path difference between the two rays must be equal to L lambda, and for destructive interference, the path difference between the two rays must be equal to N minus 1 by 2 into lambda. Here we again derive the same thing or same condition for constructive and destructive interference, but in terms of this capital D and this small d. This capital D is the distance between this slit and the screen, and this small d is the distance between these two slits. Okay, so let's start. See, let's suppose this is a monochromatic source and these two S1 and S2 are the coherent sources. Okay, now we have to observe the interference fringe at point P. Now we can easily see that the light rays which is emerging from this slit S2 has to travel some extra distance P in order to reach at point P. That extra distance is called path difference introduced in this rays. Okay, so path difference P is what? This P is what? The distance which is traveled for the light rays which is emerging from S2 minus the distance traveled by the light rays which is emerging from S1, that is S2P minus S1P. So we have to find the value of this. Now firstly determine the value of this S2P square minus S1P square, which is equal to S2P square is what? This distance. S2P square is this distance. So this is the hypotenuse for triangle P, S2 and B. So it is equal to this square plus this square. So it is equal to D square plus, now this is the X and this is D by 2. So X plus D by 2 whole square minus, now for S1P square, this is the hypotenuse for triangle P, S1 and A. So S1P square is equal to D square plus X minus D by 2, D square plus X minus D by 2 square. Now solve it. See, on the moving bracket this D square will be cancelled by this D square, and if you expand this term then we get X square plus D square by 4 plus XD minus X square minus D square by 4 plus XD. So this is cancelled out and we get 2XD. Okay. Now this is this S2P square minus S1P square, we get value 2XD. Now this is nothing but A square minus B square, so if you expand it then S2P plus S1P into S2P minus S1P, which is equal to 2XD. See, we have to determine the value of this S2P minus S1P, that is the path difference. So S2P minus S1P is equal to what? 2XD upon S2P plus S1P. See, this point from on which we have to observe the interference pattern is very close to this central point O. That's why this distance S2P is almost equal to D and S1P is almost equal to D. So in denominator we get 2XD upon D plus D, which is equal to 2XD upon 2D, or simply XD upon. So this is nothing but the path difference. So path difference is equal to XD upon D. Okay. Now see, this is the path difference introduced in these two rays in terms of small d and capital D. And in last lecture we derived the condition for maximum or minimum intensity, that for constructive interference this path difference must be equal to what? N lambda. So put the value here, x d upon d is equal to n lambda. So x is what? N d lambda upon small d. So this is the position. This is the position from this central point O on which the maximum intensity is observed, or on which the constructive interference is occur. For example, if you put 1 here, then d lambda upon we get d lambda upon d. It means that the first maxima observed from this O point at the distance of d lambda upon d. Okay. The second interference is at 2d lambda upon d, 3d lambda upon d. Okay. So this is the condition. Now, but for destructive, this is for what? Constructive interference. Constructive interference. For destructive interference, for destructive interference, this path difference must be equal to n minus 1 by 2 into lambda. And how much is the path difference? xd upon d is equal to n minus 1 by 2 into lambda. This implies this x is what? N minus 1 by 2 into d lambda upon small d. So if you put 1 here, then we get what? D lambda upon 2d. It means that the first destructive interference occur at d lambda upon 2d. Okay. So this is the condition for constructive and destructive interference. Let's understand with the help of a variation curve. See, this is in terms of xn. This n represent the order. If n is equal to 1, then it is the first order interference pattern, second order interference pattern. Okay. See, this is the axis. Now at central point O, the maxima is occur because the both light rays coming at point O at the same time will and in the same phase. So that is the crest overlap with crest, and trough is overlap with trough. So we get the maxima here. So it is like this. Goes on. Here also, and like this. This is the central point. Now first minima occur at what? First minima occur at d lambda upon 2d. Why? Because xn is what? N minus 1 by 2 d lambda upon d. So this is the first minima, that is the first destructive interference. So put n is equal to 1 here, we get what? D lambda upon 2d. So this is nothing but d lambda upon 2d. For second destructive interference, put 2 here, so we get what? 3d lambda upon 2d. So this is what? 3d lambda upon 2d, 5d lambda upon 2d. Okay, so this is, and in this side we get negative values, d lambda upon 2d minus 3d lambda upon 2d, and goes on. Okay, this is the maxima, and this is what? Minima. एक चीज ध्यान रखना, अब अभी आप एक क्वेश्चन राइज होगा कि हमें ये जो इंटेंसिटी है वो सेम कैसे मिल रही है, ये टाइम के साथ कम क्यों नहीं हो रही है, डिक्रीज क्यों नहीं हो रही है? तो होता क्या है ना कि जो भी एनर्जी, यहाँ पे एनर्जी कंजर्व होता है इंटरफेरेंस पैटर्न में, होता क्या है कि जो भी एनर्जी जो है डार्क फ्रिंज में कंज्यूम होती है, सॉरी, उससे निकलती है, तभी तो वो डार्क दिख रहा है, वो जो है व्हाइट लाइट में, सॉरी, मैक्सिमम में यूज हो जाती है। तो जितना डिसअपियर होता है डार्क फ्रिंज से, उतना ही वो कंज्यूम कर लेता है व्हाइट फ्रिंज। दैट्स वाई यहाँ पे इंटरफेरेंस पैटर्न हमें ऐसे देखने को मिलता है, इंटेंसिटी वेरी नहीं करती है। और ये पोजीशन होती है, ये किसका पोजीशन है? डिस्ट्रक्टिव इंटरफेरेंस फर्स्ट ऑर्डर, सेकेंड ऑर्डर, थर्ड ऑर्डर। करना क्या है, जो एक्सएन है ना, ये पोजीशन बताता है इस डिस्टेंस पे कितने वैल्यू पे, ये एक्सएन है, ये x1 है ना, ये पोजीशन बता रहा है कि कहाँ पे ओरिजिन से कहाँ पे फर्स्ट मिनिमा आएगा, मतलब फर्स्ट डिस्ट्रक्टिव इंटरफेरेंस आएगा। मिनिमा का मतलब है फर्स्ट डिस्ट्रक्टिव इंटरफेरेंस, क्योंकि डार्क फ्रिंज है ना, वहां पे इंटेंसिटी जीरो होती है, और मैक्सिमम मतलब वहां पे इंटेंसिटी मैक्सिमम होती है। ठीक है, ओके। So this is the interference pattern we get, and this is the condition xn is equal to what, n d lambda upon d, and this is what, n minus 1 by 2 d lambda upon d. This is for maxima and this is for minimum. ठीक है, okay. Now let's calculate what is the maximum intensity, value of maximum intensity. We had already discussed that intensity, the resultant intensity is equal to I1 plus I2 plus what, 2 root I1 I2 cos theta, and in terms of amplitude we get A square is equal to A square plus A2 square plus 2 A1 A2 cos theta. For maximum interference, cos theta is what, 1. So replace this cos theta by 1. What we will get? A1 square plus A2 square plus 2. That is, it is equal to what? A1 plus A2 whole square. And if the two traveling rays have same amplitude, then this become equal to what? 4A square. So maximum intensity is what? 4A square. And for minimum intensity, what we will get? Here. For minimum intensity, A square is what? A1 square plus A2 square, and for minimum intensity this cos theta is equal to minus 1 minus 2 A1 A2, so this is equal to what, A1 minus A2 whole square. So intensity, minimum intensity is what, see intensity is proportional to amplitude square, so this is like this. But if two traveling rays have same amplitude, then we will get what, 0. That's why this dark fringes have 0 intensity, while this maximum fringes had, while this maxima has this value of intensity. Okay, and this interference pattern will vary between this maxima and minima. So that's all. Now one thing is left, now completed. So that's all from today's lecture. Thank you.